Have you ever encountered a situation where your model performs admirably on the training data but fails to appropriately predict the test data? Well, the reason is overfitting, and regularization is the solution to such a situation. Regularization procedures aid in the improvement of a model and speed up its convergence. We have a number of regularization method on hand, and today we are going to explore one such technique, which is batch normalization. Normalization is a data pre-processing technology that changes data without changing its shape and converts numerical data to a common scale. And batch normalization is a process that is used to make neural network more stable and faster. Batch normalization is a deep neural network training technique that defines the inputs to each layer for each mini batch. It is a technique for making artificial neural network faster and more stable by recentering and rescaling the inputs of the layers. So if you feel the need to dig deeper into batch normalization, sit tight as we bring to you all the information you need right on your screen. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.
Hello everyone, my name is Shambhavi. Hope you all are doing well. So here I welcome you to the great learning on the batch normalization. So this is the topic for which we are going to discuss in this respective video. Batch normalization. Now this respective topic is belong to the neural networks, and neural networks are belong to the deep learning, right? So into this respective video, we are going to learn about the batch normalization. We'll be having a little bit idea regarding neural networks as well, right? So this is how it's going to be proceeding on. So I won't waste too much of time right here. Let me take you to the agenda that what are we going to follow up in this respective video. So the agenda goes that first of all, the very first topic we'll be learning about that what batch normalization actually is. Okay, what's that? And under this batch normalization only, first of all, we'll be dealing with that what normalization is. Okay, after learning about the normalization, I'll be taking you to the batch normalization. Fine. Moving ahead, when we have learned about that what batch normalization actually is, we'll be learning that how does this actually works out. Okay. Now, throughout the video, at some sort of cases, if I say BN, okay, so that's the short form for the batch normalization. B belongs for the batch and N belongs for the normalization. Okay. So at some sort of point, if I say Bn, so that's gonna directly represent up the batch normalization only. Okay. Now, after learning about that how batch normalization works, we shall as will be very clear about that when to use Bn and how to use Bn. Because it's not only one single thing which comes under the deep learning and the neural networks, right? There are numerous of topics, there are numerous of algorithms, there are numerous of things which are to be followed up. So now what's the case that where Bn is used and how to use Bn and that respective case. This is a very important thing that you should have the knowledge of. After that, now when you have used up the Bn for a certain case, then how to evaluate out the batch results, evaluate that out, how to understand the results in that respective case. Then in the batch normalization, we have two things. The first one is the regularization and the second one is the normalization. Okay. So here we'll be going through in detail between these two topics, which is the regularization and the normalization. Okay. Moving forward, I'll be taking you that why is this method so important? Why is the need for learning this respective topic? Okay. What's the respective need for learning this topic? Why is that important? Everything I'll be covering up here. The side effects. Now, if anything is important or if we are learning any respective thing, it's damn sure that it would have some or the either side effects and some or the either advantages, right? So we'll be dealing with the side effects and we'll be dealing with the advantages, both of the things right here. Fine. So hope I am very much clear that how are we gonna proceed here with the batch normalization, what are the topics which we are gonna cover up, and how is this actually gonna proceed up further, right? So let me take you to the very first topic here. That's what is batch normalization. What do we understand from this respective term first of all? It's the very important thing firstly that you should be aware of before learning any other respective topic, right? So now if I talk about the batch normalization, so I'm going to divide up this respective term in two ways. The first term will be my batch and the second term will be my normalization. So first of all, I am going to discuss about the normalization here. Okay. Now, what do I mean from normalization? So that's a pre-processing tool. Okay. For a data, it's one of the pre-processing tools that it like without disturbing of the shape of the data, it converts the numerical data to a common scale. Okay. Now, first of all, I told you that this is one of the things which lies under the deep learning. In the deep learning, we have neural networks, right? So this respective topic belongs to the deep learning. Now, it is one of a tool. You could say it's one of a tool which is used for the data. Now, what sort of tool and how is it used for the data? So now let's say you want to convert up the numerical data to a common scale. Okay, and that's so without disturbing the shape of the data, whatever is the real shape. Now, what do I mean from the shape of the data? So let's say you are having up a data and that's somewhat of shape 5, 4, 5 cross 4, or the things like that, right? Now, whatever is the shape of my data, I really do not want to at all remain 3, 2. I do not want that out. And my other condition is that I as well want to bring up that numerical data to the common scale. So normalization is one of the tools, is one of the method which best suits for the given for the given thing which I mentioned up. It will best tool. Okay, it's up. Okay, so here as I mentioned that it is one of the pre-processing tools for the data that without disturbing the shape of the data, it brings up the numerical data to the common scale. Okay. So first of all, I hope that I am very much clear that what normalization means. Okay. Now, when you are now well aware with the normalization that what it actually is, let me take you to the batch normalization. So now that's one of the process which is used for making up the neural networks more stable and faster. Right. Now, as I told you that it deals with the neural networks, right? So now let's say you want to make the neural networks more stable and faster. Whatever neural networks or whatever the idea you are working with in that, you want to make up these neural networks more stable and more faster. So yes, batch normalization is a process which is used to do so, right? Normalization is completely converting your numerical data into the common scale without disturbing the shape. And your batch normalization helps you to make your neural networks more stable and fast, right? So I hope that I am as well very much clear with the batch normalization, right? Now, how do we make up the neural networks stable and faster, right? What's the way for doing so? We simply learn that this is batch normalization and it's used for making the data stable and faster, right? Now, what's the way for doing so? So we for making the neural networks become more stable and faster, what we do that in a deep neural network we add up some extra neural network. This batch normalization is actually worked upon and your neural networks become more stable and more faster. So here you could see that the extra layers which you are adding, through those extra layers only, your neural networks become more stable and faster, right? So batch normalization works for making the neural networks more stable and faster, and these are made stable and faster by adding extra layers onto your neural networks. Right? In your deep neural network, the extra layers are added, and by the addition of those respective extra layers only, your neural networks become more faster and stable, and thus your batch normalization process is completely applied. Right? So, hope I am very much clear with these three things to you, that first of all, what normalization actually is. If I differentiate the batch and the normalization, so into that, the first term which comes is the normalization. That's necessary to understand. So I hope I am clear with that. Moving forward, I told you regarding the batch normalization, that what actually is, and thirdly, I cleared you that how we make up the neural networks more stable and faster, right? So hope I'm very much clear with all of these respective points to you. Now let's move further and discuss the next topic for our batch normalization. So we just learned about that what batch normalization is, right? Now let's jump on to our second topic and let's understand that how does batch normalization actually works out. Okay, what's the procedure or what's the respective method which is required and for the batch normalization to work, right? Let me take you to the next slide right here. And here we go. Right. Now, we learned about batch normalization, that it is used for making up the neural networks more stable and faster, right? But how does it do so? So we learned that it adds up some extra layers onto that, and it does out and makes our neural networks, deep neural network, more stable and faster. Now, how does this batch normalization actually work? What's the working of it? Now, there is one simple point, and through that respective point only, my batch normalization working is completely explained. Here, I do not want you to be very much confused in the terms or very much confused in different types of formulas or the sentences. Right? So, I had taken up a very simple here, and I'll be explaining you the same by subtracting up the layer input by the mini batch min. Now, first of all, let's understand why I was using up a term here, that's the mini batch, right? So, what does that actually mean? Right, mini batch means a subset for the complete training data. So, whatever the data you are actually training, okay, you have the data and you train that out, right? This is what is happening right now in the deep learning and the sort of things. If I say about in very simple, yeah, you have a data and you train that out according to your needs, according to your requirements, and according to the conditions for which you are using up that respective data, right? So, that data which I am talking about, that is being trained. So, mini batch is actually a subset. It means a small part. You could simply say a small part for the complete training data. A subset means it is a subset for the complete training data. Okay, whatever the data you are using for the training and for all those things, mini batch acts as a subset. Okay, now what do? We subtract the layer input by the mini batch min. Okay, so with the mini batch min, what do? We simply subtract the layer input. Okay, we simply subtract up the layer input by the mini batch min. It means that the whatever is the mean for the subset of the complete training data, we subtract the layer input by that. Okay. Now, whatever we have got out, then we divide it by the mini batch standard deviation. Then what we do? Then from the subset for the complete training data, we find out the standard deviation for that, and then the subtraction of the mini batch mean and the layer input is divided by the mini batch standard deviation. The batch normalization normalizes the layer. So now after doing up these two very simple lines of procedure, the batch normalization, it normalizes up the layers, right? Let me tell you once again in a detail, because yes, I know it's a little bit of confusing, but once you get this out, you are not gonna forget this for your whole life. Okay? First of all, I would again repeat the mini batch. It's a subset for the complete training data. Okay, now the subset is the same which you did learn in the sets and functions. Hope you have already dealt with and hope you have learned about the sets. Not right here, but even classes, younger classes, if you did take up the mathematics, so you must have learned about the sets, right? Now, into that we learned about the subset as well, right? Now, that's a small part of the set which you are having. Okay. Now, treat up here as the complete training data is a set. And from that respective set, we are trying to take up a small part or a small set. So, that small set from the complete training data is called the subset for me. And that subset is known as the mini batch, right? So, firstly, hope I am very much clear with this particular thing that what do we meant from the mini batch. Moving forward, how do we calculate out the working of the batch normalization? So, what do? We simply subtract up the layer input by the mini batch mean. So whatever is the subset for the complete training data, we find up the mean for that. Okay, and the input is subtracted by that respective mean of the subset of complete training data which we did find out. Then whatever the result you get, that is divided by the standard deviation of the complete training data. Okay, so whatever the answer you get out from there, the standard deviation for the mini batch is divided by the subtraction layer input which we got the subtraction value at that respective place. Okay, and after the successful happening of this particular procedure, the batch normalization normalizes the layer. So when these two steps are actually applied out, after that, the batch normalization normalizes up the layers. Okay, and this is how the batch normalization actually works, right? So, hope I am very much clear here regarding the working of the batch normalization, that what's the procedure and how this actually works out. Now, after learning that how does the batch normalization actually work, what's the procedure here for the working of the batch normalization, what is a mini batch, after learning all of these respective things, now it's the turn to learn about that when and how to use the batch normalization. When I wrote up here BN, so as I told you in the very starting of this respective video, that BN means the batch normalization. Okay, so let me take you further here and let's understand that how does the BN work and when does it, and sorry, how and when it is actually used out. Now, If I talk about first of all that when the batch normalization is actually used, so in that respective case, I could mention up that whenever you want that the outputs of the previous layer shall be normalized, then in that case, the batch normalization is used. Okay. Now, whatever the output you did got from the previous layer, now what is batch normalization? Into that, what we do, we make our neural networks more stable and faster, right? This is actually what comes under the batch normalization, correct? Now, and how does these becomes more stable and faster? So for that, we add up some more layers into that. Now, whenever you want that the previous layer, the output of the, let's say you did add up some previous layers and you have the output for those. And whenever you want that, you want to normalize up the output of the previous layers into that, the batch normalization is the technique, is the tool which is completely used up. Okay. Now, let me once take you to the very starting where I told you about that what meant up from the normalization. Right here, I told you that without disturbing the shape of the data, we try to bring that into numerical data from we try to bring the numerical data to a common scale. That's known as normalization. So this is what only I meant here that when you want to normalize the output, normalizing the output means that bringing up your data from, let's say, bringing up your data from numerical values to the common scale without disturbing of the shape of your data. So into that we say that whenever is the like whenever this is the requirement, whenever this is the case, and you want to normalize the output of the previous layer, it means normalize the output means you want to convert the numerical values of the previous layers to the common scale, then even without disturbing up the shape. So that's the case, that's the use when you use up the batch normalization, right? So I think I made it clear, but let me once again give you a very quick recap because I'm not too much sure that you maybe and you did understand of this thing or not. So once again, let me speak it out. Now, whenever you want that, first of all, let me read up the sentence. Okay, whenever you want to normalize the output of the previous layers. Okay, normalize the output of the previous layers. It means whenever you want that the output of the previous layers shall be converted from numerical values to the common scale without the disturbing of the shape, in that case you use batch normalization, right? So hope first point is very much clear that what batch normalization is first of all used for. Second, while using the batch normalization, learning becomes more efficient. So, to avoid up the overfitting, it can be used as a regularizer. Regularizer and the regularization I had already covered up further in this respective video only. But right here, let me give you first of all the idea that what overfitting is. Okay, we know that the deep learning deals with a numerous of parameters, right? We have many parameters for the training and testing, right? In which the deep learning actually deals with. Now, sometimes it can happen that the network often loses up the control over the learning process, whatever the training and the things we are doing. As I mentioned up here, learning, right? So sometimes it could happen that the networks often lose the control over the learning process, right? So in that, what happens? The model which you are actually training and the model which you are actually learning, what it tries to memorize each of the data points. Whatever data points are present into that respective model, it tries to memorize them. Okay. So, and when it tries to memorize the data points, so in that case, what it causes to perform well on the training data but poorly on the test data set. So whenever it tries to remember up the data points, so in that case the training data is well worked and everything is quite fine in the training data, but the testing data is tested very 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 poorly. It means it doesn't give you the good results when you are testing up your data set. So this is what is called as overfitting. Okay, let me give you once again a recap what overfitting actually is. Okay, so if I talk about the overfitting once again, so here what happens that the deep neural networks deal with many parameters, right? The deep neural networks deal with the many parameters which are used for the testing and the training, the two terms, right? Sometimes it may happen that the networks lose up their control over the learning process. Learning process means over the testing and the training of the data. Sometimes it happens that the networks lose up their control, right? So in that case, whatever the model you are learning, it means whatever the model you are training and testing, what it tries that it shall memorize the data points. Now, when it has memorized up the when my model has memorized up the data points, so into that case the training of the data is performed very well. There is no such problem in training of my data, but when it comes to testing of my data set, it gives you a lot of problems while testing up your data. Okay, it gives you a very poor result into the testing of your data. That's what is called as overfitting. So, to avoid up this respective overfitting, batch normalization can be used as a regularizer. Okay, so to avoid up these cases, batch normalization acts and works as a regularizer. Fine. So, when you are dealing up with the batch normalization, your learning becomes very much efficient. Okay, and learning is when learning means training and testing of my data becomes very much efficient. Now, when my training and testing of data is efficient, there only one thing left is one thing is only left out, which basically could cause up some of the problem. So that is called as overfitting. So to avoid that respective problem, so to avoid up that respective overfitting as well, my batch normalization can be used as the regularizer. Okay, so hope I am very much clear with the second point as well. Third is that how to use, so for standardizing the inputs and the outputs, you add up the layers in a sequential model. Okay, so whatever the sequential model you are having, what do? You add up the layers onto your sequential model for standardizing the inputs and the outputs. Right. So in that case, what has happened? That the layer is added to your sequential model, and into that respective sequential model, the input and the output are actually worked as the standardized. Fine. Now, hope I am very much clear with all of these 3 points to you, that when and how to use the BN, when and how to use the batch normalization. So, whenever you want to normalize the outputs of the previous layers, okay, in that case, first of all, the batch normalization is used. Second, when it is used, when the learning becomes more efficient while using batch normalization. So, to avoid overfitting, it could be used as a regularizer, right? And the third is how to use. So, for standardizing the input and the output, the layer is added to the sequential model, right? So hope I am very much clear with that how and when to use the batch normalization, right? Hope you got up this respective topic as well very well, because it's the important one. You shall be very well actually aware of that when to use the BN. Like as I mentioned in the very starting, I would again mention that in deep learning you have many topics, many tools to be worked upon. Then what is the case where this shall be used? Okay, so hope I am very much clear with that. Let's jump on to the next topic for our discussion. Now let's understand that how to evaluate out the BN results. Means that how to evaluate out the batch normalization results. Till now, we learned that what batch normalization is, and after that, how does this works, when and how to use this out. Now, when you did learn that how it works and you have used in the respective case, now what's the way for evaluating out the batch normalization results? So here we go with the evaluation of the BN results. Okay, now uh, for the batch normalization results, a transformation is applied, which means either two of the results. Now we have either here two results. Okay, in those two results only, there would be some way, there would be some value, or there would be some method which in which your batch normalization will lie in either of these two cases. Okay, so whenever the transformation is applied in the batch normalization, it maintains either of these two results. The very first one is that your mean, it means the mean output will be close to 0. Okay, now right here when we learned about that how does that actually works, we learned about that how BN works. There we learned about the mean of the mini batch, right? Mini batch was a subset of the complete training data. Remember I told you that respective thing. So mini batch was the subset of the complete training data. And there I told you the two things. First of all, whatever the layers are there, from that layers we subtract the mean of the mini batch. Now, that respective output could be close to 0. The mean output close to 0. The very first one case which we have here, when you apply the transformation in the batch normalization, so that is the mean output, right? The mean output which you get, that shall be close to 0. Again, when we were dealing with that how does this batch normalization works, there again I told you that after the subtraction of these two things, it is divided by the mini batch standard deviation, right? So the output for the standard deviation shall be or will be close to 1. Okay, these are the two results which can be put up after a transformation is applied in the batch normalization. Now, the batch normalization works differently during the inference and during the training. What is our inference? Training, you all are very well aware of that what training actually means about. So there, that's the true thing that you are aware of. What is this inference? Now, in deep learning, we have this technique which is inference, right? It means that it's a use of a process which is used to train the model, okay, for making up the prediction against the previous unseen data. Whatever the previous unseen data you are having, the data which is not seen, the previous data which is not seen, so into that respective data, against that respective data, this inference is a process which is used for training the model to make the predictions. And on what type of data the predictions are made against, not in the favor, against the previously unseen data. So this respective thing refers to the inference, right? Now, this is what is mentioned and referred to the inference. And when I talk about training, so training completely comes under your training of the data. So now the batch normalization which we have up here, it works differently in both of the cases. It works differently in the inference while the time of the inference, and even during the training as well. The batch normalization works in a different manner. Okay, inference I would again repeat, because into this lecture, whatever I am delivering in this respective video, there are very, very, very useful terms which are used up and which are actually very useful if I'm saying that out. So make sure that you listen to me very carefully. Inference, I would again repeat that it's a process for the training of the model to make the predictions against the previously unseen data. So, how are the BN results evaluated? So, as the BN, how does the batch normalization works? It's completely related to that particular thing. The mean output will be close to 0 and the output standard deviation is close to 1. So when a transformation is applied in batch normalization, which maintains either of the two results, the mean output close to 0 and the standard output on the output standard deviation close to 1. Okay, so now this is one thing which is actually to be maintained and it is actually looked up here. That's the transformation. Okay, so whenever transformation is applied in batch normalization, transformation means to transform something, right? Whenever it is applied in BN, it maintains any of these two results. The first one is either the mean output will be close to 0 or the output standard deviation will be close to 1. Okay, and the batch normalization works differently during the inference and even during the training. So for both of the cases, batch normalization works in different ways. It's not the case that for each and everything the batch normalization will work similar. Okay, so in both of these cases it works differently. So hope I am very much clear that how to evaluate the batch normalization results. How are these results evaluated and how does these things actually work about? Right now, let's jump on to the next topic for our batch normalization. Okay, now let's understand about the regularization and the normalization in the batch normalization. What are these two terms and how are these used in the batch normalization? Let's learn about those. Let me take you to the second slide. Convergence and generalization. In training of the neural networks can be improved using the batch normalization. Now, using the batch normalization, what you could do in the training of the neural networks, convergence and generalization. These two terms can be improved up here. When we talk about the batch normalization, so it is actually simply analyzed as a very basic block. It is analyzed as a very basic block. What does it contain? It contains upper kernel layer, a nonlinear activation function, and a batch normalization layer. Now that is why we say that batch normalization is analyzed by a very basic block. Basic block means that it contains not too many things. It simply have some of the things contained in it and it's a very basic block. So batch normalization is analyzed as a basic block, and what are the things which it actually contains? It contains a kernel layer, a nonlinear activation function, and a BN layer. That's your batch normalization layer. Okay, so in training up the neural networks, convergence, and the generalization could be improved using the batch normalization. Second, the batch normalization is analyzed as a basic block which consists of a kernel layer, a nonlinear activation function, and a batch normalization layer. Okay, next, there are three aspects which are used for understanding this respective phenomena. The very first one is that the batch normalization is viewed as an implicit regularizer. It is seen as an implicit regularizer and as an explicit regularization. Batch normalization decomposes into the Pn and the gamma decay. Now, listen to me very much carefully for the next few minutes. That first of all, Bn is viewed. It is seen as an implicit regularizer, right? Implicit regularizer, and it is as an explicit regularization. And when we talk about the explicit regularization in the batch normalization, so it can be decomposed into the gamma decay. Fine. The regularization shows the converged training with effective and large max learning rate. The regularization, which I was talking about, what it shows you the converged training. Whatever the training has been done, it shows you that perspective with the maximum learning rate and an effective learning rate. Okay, so in that case, it shows you the converged training with effective and large maximum learning rate. And when I talk about by using the statistical mechanics, generalization of Bayes is explored. So generalization of the batch normalization can be explored by using the statistical mechanics, right? So this is how this regularization and the normalization acts upon in the batch normalization. Hope I am very much clear with this particular thing. Let me take you to the further slide and discuss about other topics which come under the batch normalization. Now, let's learn about that. Why is this method so important? Why are we actually learning up this respective batch normalization? And why is this method important? Why we are actually learning up this right here? Fine. So let me take you here to the further things, right? Now, I have listed up here three very important reasons for being this batch normalization so important. Okay, the very first one is that it helps you to solve up a problem which is known as internal covariate shift. Now, a new term introduced up here, that's the internal covariate shift. Now, what is this first of all? So let me tell you in a very detailed way that what's internal covariate shift. Now, it is the change in the distribution of the network activations. Okay, there is a change into the distribution of the network activations, which is due to the change in the network parameters. Okay, while the training is done, there is some change in the network parameters, right? Now, due to that respective change, there is the change in the distribution of the network activations. That respective procedure is called as internal covariate shift. Okay. Now, if I again talk about the internal covariate shift, so whenever you are training up your data, right? Now, whenever you're training up your data, so in that respective cases, it can be the case that there is some change into your network parameters. Okay. Whatever the network parameters you are having up, there could be some change in all of those things, right? Now, if there is one slight change into your training of the data, it is surely gonna affect the any other else things into your data, right? So yes, when you have the change into your network parameters, which is changed while the training of the data, there is a change in the distribution of the network activation. So, however the network deviations are distributed, there is the change in that respective thing. And this respective procedure is only known as internal covariate shift. It means that there is a shift, there is a change in the distribution of network activations. And all of the things which are working up here, these all are worked as in the internal form. So that's the reason it is called as internal covariate shift. Okay, first of all, hope I am clear with that what is internal covariate shift. Now, so batch normalization is the tool which helps you properly to solve up this respective problem. It means that whenever there is a change in the network parameters during the training, so there is a change in the distribution of the network activations as well. So to solve up this respective problem, there is the method which we have and which we are learning from the last half an hour, and that's the batch normalization. Hope I am very much clear, first of all, regarding the internal covariate shift. Secondly, it helps you to solve up the vanishing gradient problem. Okay, now, it even helps you to solve up the vanishing gradient problem. What is this vanishing gradient problem? Let's learn about, first of all, understand that what's the vanishing gradient problem. Then we will be seeing that how it is helped in solving of this respective problem. Vanishing gradient problem is such a type of a problem in which let's say we have an example of that. Okay, so it's a problem. The vanishing gradient problem is an example. Let's say you are just training up your some deep neural network. Okay, you are training up your deep neural network. So sometimes it happens that it basically behaves somewhat in an unstable behavior, right? Whenever you are training your deep neural network, so sometimes it happens up that unstable behavior is often seen, right, while training up of the deep neural network. That respective thing is called as vanishing gradient problem. Okay, and when this respective vanishing gradient problem occurs, it occurs when a neural network is long and even it is complex, that this neural network is not basically it is not able to back propagate the gradient information. Whatever the gradient information is there, it's not able to back propagate out that because it is long and complex. So this vanishing gradient problem occurs. And vanishing gradient problem, what is this? So while training up of a deep neural network, sometimes it is seen that there is an unstable behavior. That is the behavior which is not stable. Unstable, a different behavior is there. That respective thing is called the vanishing gradient problem. Okay, so to solve out that respective problem, the batch normalization helps us to do so, right? So to solve up this respective problem of the vanishing gradient means the unstable behavior while the training of the deep neural network. So to overcome up this respective problem, batch normalization is completely used up. Now, for next thing which goes up, that why is this method this much important? So for all the layers of the neural network, it helps to learn at the normalized rate. So whatever the layers of the neural network we are having, it helps those layers to learn at a normalized rate. Okay, at a normal rate, it helps for all of those layers of the neural networks to learn, right? So this is the third reason that why is this respective method so important, right? So I did mention up here three respective ways that why we say this method is important. The very first reason is that it helps you to solve up a problem which is known as internal covariate shift, right? It helps you to solve up this respective problem. Second goes that it helps you to solve up the vanishing gradient problem. And the third one is that for all the layers of the neural networks, it helps you to learn at the normalized rate. Fine. Now, it helps you to solve up these important problems which are caused using the training of the deep neural networks. And during all of these things, it helps you to treat up these sort of reasons, these sort of problems. That's why. That is the reason we are starting this, and that's the complete reason that why we say this respective method is so much important, right? So hope I made up this particular thing very much clear for you that why is this method important. Whenever you are learning a respective topic, the detail of that particular topic and why to use this method, why is this method important, these are the very important things that are to be taken care of and that are to be actually learned very properly, right? So hope this particular topic is as which very much clear to you. Let me take you forward in the batch normalization, and let's see that what's the next thing that we are going to learn up here. Okay, so now let's learn about that. What are the side effects of batch normalization? After learning this much in the batch normalization, how it works, what's the procedure, how the results are evaluated, regularization, generalization, everything learning after all of these respective things, we have came upon to this respective topic that what is the side effect of batch normalization. Right, each and everything actually has a side effect. There is no such doubt in the respective place, right? So let's learn about the side effects of batch normalization. Now, the very first is that regularization is the side effect of batch normalization. Regularization, yes, it's actually the side effect of batch normalization. Regularization we just learned few minutes before, so I'm not going to repeat out that again so as to waste out our time right here. So the very first side effect of the batch normalization is the regularization. For avoiding the overfitting, you should not rely on the B. Okay, we did learn some few minutes before that it is used for like remove the overfitting as an act as regularizer. Right, we did learn so. But yes, it do. But we can't rely on the batch normalization for avoiding the overfitting. It helps you to avoid the overfitting. That's so true. It acts as a regularizer, and that so helps you in the avoiding of the overfitting. That's the very true thing. But for the correct thing, you can't rely on the batch normalization. Okay? See, doing something is the other thing, and relying and believing on something is the other thing, right? You can do and the overfitting and into the batch normalization, but you can't rely for avoiding the overfitting in the batch normalization. Okay. Now, between the training examples, batch normalization breaks the independence. When you are doing up the training, okay, so in the training examples, whatever the training examples you are having, so between those training examples, this batch normalization, it breaks up the independence. Okay, so whatever the independence was there between the training examples, it breaks those out. Now, this is one of a very uh, very important side effect of the batch normalization, right? For language modeling and the time series task, batch normalization requires up the special attention. Now, what do I meant from this respective line that for language modeling and time series task, batch normalization requires up a special attention? So it means that whenever you are performing up any language modeling or whenever you are performing up any time series task, so you shall be very much careful while using up the batch normalization. Okay, you shall be very much careful as you were careful for the other things. More than that, you shall be paying attention towards this language modeling and the time series task. If you are performing that through the batch normalization. Okay, it is the simple meaning that it requires up the special attention, means a little slight thing could destroy each and everything into your model. Okay, could give you the false results, right? So, in that respective manner, it was mentioned up here that language modeling and the time series task in the batch normalization require the special attention, right? So, there are four side effects of batch normalization, which I did mention up here for this perspective. Let me take you once again through all of these four. Regularization is the side effect of batch normalization. Very true, right? It's one of the biggest side effects of the batch normalization. For avoiding the overfitting, you should not rely on the batch normalization. It helps you to do the overfitting and acts as a regularizer. That's so true. But to avoid the overfitting, you should not at all rely on the batch normalization. Between the training examples, batch normalization breaks the independence, right? So, whenever you are putting and using the batch normalization between the training examples, so it completely breaks up the independence. And for the language modeling and the time series task, batch normalization requires up the special attention. So these are the four side effects of the batch normalization, which I did mention up here for the most important side effects for the batch normalization, right? So hope I am very much clear what are the side effects of being. Now, if anything is having side effects, it is surely going to have up some or the other advantages, right? Then why, if it is not having, then why are we learning this out? So yes, absolutely, it is actually having up some advantages of batch normalization. So next slide is based upon the advantages of the batch normalization. So let me quickly take you to that respective place. Now, let's learn about and move to the next topic here that we are having up. So, the next topic that we are having up here is, and we are going to learn about that what are the advantages of using the batch normalization. Okay, advantages of using the batch normalization. What are these? Let's move forward and look upon that. So here I have mentioned up four advantages of using the bean. That's my batch normalization. So first of all, by using the batch normalization, It's simplified and easy to create the deeper networks. So for creating up the deeper networks, batch normalization is simplified and as well it is easy. Okay, so into that respective case, the use and the very first advantage of using the batch normalization is it's simplified and it's easy to create the deeper networks. Fine. Moving next, the another advantage for using up the batch normalization is that the training process speeds up. Okay, it means the process which is used for training up the models, for training up the deep neural network models, that respective speed increases. Okay, the process for training up the models increases, and that's the another advantage of using up the batch normalization. Okay, next, by using the batch normalization, it's easy to handle up the internal covariate shift. Right some minutes before, I told you about the internal covariate shift, right? We did learn about this internal covariate shift once more time into the thing. Let me take you where did we use this out? And I guess we did use it out somewhere. I when and how it's the how batch normalization works, how to evaluate regularization, no? Right here. We did learn about this internal covariate shift. That why is this method so important? There as well, I mentioned you up that it helps you to solve up a problem which is known as internal covariate shift, which is basically a shift in the layers of the neural network. So that's somewhat which it is acting up here. It helps us to solve this respective problem. That is why right here I mentioned up that it is one of the method, it is a batch normalization. So with the help of this, it is easy for us to handle up the internal covariate shift. Okay, next. By using the batch normalization, the loss parameter gets smoothed. It means that the loss parameter which we have up into our models, that gets smoothed, that gets easy, right? This is what is the another advantage of using the batch normalization. So there are four very important advantages for using up the batch normalization, which again I am going to repeat it up here that it is simplified and easy to create the deeper network. It's simplified and easy to create up the deeper networks. The training process speeds up by the use of batch normalization. It is easy to handle up the internal covariate shift, and the loss parameter gets smoothened by the use of batch normalization. Great. So, if anything is having the disadvantages, so obviously it's gonna have up some or the other advantage, and that's the only reason that we are learning that out. So, after learning about the side effects of the batch normalization, these are the advantages as well, and these are the advantages that why we did learn about the batch normalization, right? So, hope I am very much clear with this particular thing to you that what are the advantages of using the batch normalization, right? So, now let me take you to the summary of this respective batch normalization topic which we were covering right here in this respective video. Let me take you to the summary of this. Okay, so now here is the time for a discussion of the summary of the batch normalization. So I'll be giving you a quick recap of all of the topics which we discussed up here until the batch normalization. So let me take you back from the very starting from where we did started. we started with the very first topic, that what a batch normalization actually is. Okay, so first of all, we did learn about that what's a normalization. So we were actually dealing with that. It's a sort of tool that changes the data from the numerical data to the common scale without disturbing the shape of the data, right? So this what is meant by the normalization. Batch normalization was a process which is completely used for making up the neural networks more stable and more faster. And how do these neural networks become more stable and faster? So, in a deep neural network, what we did, we add up some extra layers. So, by the addition of those extra layers, this respective batch normalization works more stable and faster. So, this was what is about the batch normalization, the normalization, and the things. Second, we discussed that how does the batch normalization work. So, what the working of the batch normalization is super simple. Simply, first of all, you need to understand one term which is called as mini batch. So, mini batch is known as the subset for the complete training data. So, whatever is your complete training data, so mini batch is a subset for that. So, what we do by subtracting up the layer input by the mini batch mean, first of all, whatever the subset for the complete training data is there, we find out the mean. And the layer input is subtracted by the mean which we did found. Whatever the output is received, that is divided by the standard deviation of the mini batch. And the batch normalization normalizes up the layers. So this is how the batch normalization actually works about. This is the complete idea and even a very simple idea for the working of the batch normalization. Now, when and how to use the bin. So whenever you want to normalize the output of the previous layers, then first of all, in that respective case, you use the batch normalization. Now, in the batch normalization, learning becomes more efficient. So, it can be used as a regularizer. The third, that for standardizing the input and the output, the layer is added to the sequential model. So, to the sequential model, a layer is added for standardizing the input and the output. So, this is how and when you have to use the batch normalization. How to evaluate out the BN results. Now, we have as soon as you apply up a transformation in the BN, it maintains any of the two results. The first one is that the mean output will be close to 0. Second, the output or the output standard deviation will be close to 1. So these are the two things which it maintains whenever a transformation is applied in the batch normalization. And the batch normalization, it completely works different during the inference and during the training. So the both of the things in both of the cases, it completely works in a different manner. Next, we saw about the regularization and the normalization in the brain. So we saw that in the neural networks can be improved by the training of the convergence and the generalization using the batch normalization. It is analyzed as a basic block, and what does it actually contains? There are three things. One is a kernel layer, second is a non-linear activation function, and the third one is a batch normalization layer. There are in total three aspects which are used for understanding these phenomena. So, the very first aspect is that batch normalization, it is viewed as an implicit regularizer, and as an explicit regularization, batch normalization can be decomposed into the gamma decay. The regularization shows the converse training with effective and a large maximum learning rate. And generalization of batch normalization can be explored by using the statistical mechanics. Then we learned that why is this respective method so important that we are learning it out here. The very first reason is that it actually helps to solve up a problem which is known as internal covariate shift. Secondly, the problem of the vanishing gradient can as well be solved by the batch normalization. Third, that for all the layers of the neural networks, it helps to learn at a normalized rate. So it helps for all the neural network layers to learn at a normalized rate. Learn means here I am referring learning to the training and the training which is done. What's the side effect of the batch normalization? So, very first side effect is the regularization. Secondly, that for avoiding up the overfitting, we can't at all rely on the batch normalization. Third is that between the training examples, batch normalization breaks the independence. And whenever you are dealing with the language modeling and the time series task, so into that respective case, batch normalization requires up the special attention. While learning the side effects, there shall be some advantages that like for learning the side effects, not only we learn this one or for this batch normalization, right? So the advantages for using up the batch normalization, it is simplified and as well it is easy to create up the deeper network. The training process is speeds up, the training process increases while using the batch normalization. To handle the internal covariate shift, it is very much easy while using the batch normalization. And last but not the least, the loss parameter gets very much smoothened while using the batch normalization. So, hope you got a very good understanding and a very great learning right here about the batch normalization, right? So, this was all about which we wanted to learn about the batch normalization in this respective video. So, thank you so much.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.